Let's go ahead and get started. Kim, can you advance the slide, please?
Yes, I can. All right, there you go.
Okay, great. Thanks, Kim. Hello, everybody. Thank you for joining us today. As I mentioned, this is Seabird University 2021. Today, Dr. Kim Martini will be talking about the SUNA V2 UV nitrate sensor. So thank you for joining us. We're looking forward to this session. This is a brand new session for us. It's been requested in the past, and so this is the first time we're trying it this year. So just a little bit of information before we start going. We're using the platform Teams Live. This is Microsoft Teams Live. So you can see us, but we can't see you. And everything we show and display and say has a slight delay between when we do it and when you see it. That being said, this is still live. So if you have any questions, you can ask us in the Q&A feature of Teams Live. Also, if you need closed captioning, you can turn that on in the settings of Teams Live. Next slide, Kim. So the Q&A and the settings are on the top right of your screen. To turn on closed captions, you can click on the little gear icon and turn that on in the settings. And then for the Q&A, if you click on that little chat box, that's where we'll be able to see any questions that you type in and send to us. So that's a great way to ask us any questions about the SUNA that you would like us to cover, or anything maybe about the webinar platform. If you can't hear us, if you can't see things clearly, please let us know in the Q&A. That's a good way to get in touch with us. So as mentioned, this is the last day of our October Seabird University sessions, and we'll be covering the SUNA V2 nitrate monitoring sensor. Dr. Kim Martini is going to be teaching this one. Next slide. Okay, and just a little bit about the format, same as what we've been doing before. Class is about 1 hour long of teaching with approximately 30 minutes of Q&A and review of any additional material that you would like us to cover. Questions can be asked in the Q&A feature in Teams. That's a great way to get in touch with us. And if you have additional questions, you can contact our technical support team at seabird.com/support-team. If you missed something, or if you know someone that wanted to attend but couldn't attend, we're putting all the recordings up on our website at seabird.com/SBU2021. I'll put a link to that in the chat so you can all see. Next slide. Okay, and we are your instructors for Seabird University. My name is Greg Ikeda. I am the Senior Content Development Manager here on the Seabird marketing team. Prior to that, I was on the Seabird technical support team. So I spent a lot of time learning about our equipment, talking to people, teaching people how to use it. And there's a good possibility that I've worked with some of you before. Prior to Seabird, I went to the University of Washington and studied oceanography and spent a lot of time at sea. I've been using Seabird equipment for approximately 11 plus years. And aspect of the ocean that scares me most is big waves. I think all the animals are fine, but big waves are just really scary to me. Kim, go ahead and take it away.
All right, thanks, Greg. And I'm Dr. Kim Martini. I'll be teaching the course today. So I'm a senior oceanographer at Seabird Scientific. So that means I work a lot with the data and sensor performance and understanding how it works in the ocean, and I teach. I've been at Seabird for 5 years. I've been using Seabird equipment for over 17 years, and I've spent over 100 days at sea. So I've also worked with the SUNA before, putting it on a towed body and dragging it through dragging it around the ice in the Chukchi Sea in the Sea Spring. So what aspect of the ocean scares me? Definitely horseshoe crabs. I grew up on the East Coast, and I spent a lot of time at the beach, and I know it's absolutely irrational, but I think they're great creatures. I just kind of want to look at them from afar. I don't want them to be close. So with that introduction, I'm going to get started on what we're going to cover today. So we're going to talk about the SUNA workflow for moored applications. This unit is designed for new and beginner users, and it's going to cover the following material. As Greg indicated before, there is a lot of material for SUNA. There's a lot of different applications too, but we're just going to be covering moored stuff today. If you do have questions, please ask. Because that's a really great way for us to know, and next time we teach this, we can add that material in as well, because there's a lot about the SUNA, and so we want to make sure we know what questions you have and what's important as well. So we're really going to just do a brief intro. I'm going to show you how to set up the instrument. We're going to verify its functionality, and we're going to prepare the SUNA for deployment and just do recover and connect to the instrument as well. So some real basic stuff here. Okay. So this is what a SUNA looks like. If you've seen one before, SUNA stands for Submersible Ultraviolet Nitrate Analyzer. And so what it effectively is, it's a in-situ spectrophotometer. So we're shining a light on the ocean, and then we're going to actually get the nitrate concentration from that. There's just a couple of things that I wanted to go over here in terms of the actual instrument itself. On board, we can communicate it with multiple ways. So it's an RS-232, a USB or an analog or SDI-12 communications. If you want, you can get it optional internal 2 GB memory. We also have a mechanical biowiper for high fouling environments. So this is an optical sensor, and you need to keep those optics clean, and the biowiper does that. Also part of it is the lamp. So this is spectrophotometer, you need light. So there's a lamp in there, and then an integrated spectrophotometer. And also it comes in between that, there's a 5 or 10 milliliter path length. So that depends on how much fouling, if you're going to have a lot of suspended sediment. And that's how to make those choices and make that choice for your application as well. And also you can get this with a titanium housing that's rated to 500 meters. Okay. So what does the SUNA look like inside? So I talked a little bit about it. So really the basics of what the actual sensor looks like. So this is based on technology that was developed at MBARI. So what we have is, if you'll see the SUNA, there's a little notch in it, and that's actually where the sensing goes. So that's the sample volume in there. On the left, you'll see that we have a UV light source. So that's a stable deuterium lamp that provides a range of light in the wavelengths of the UV spectrum that goes through the seawater, and then you're going to actually measure that with the spectrometer. And then that measures it from the wavelengths that are shown there. Okay. How do you find this nitrate concentration from the UV spectrum? So every time the lamp turns on and every time the spectrometer makes a measurement, it takes a lot of counts from the actual, it's going to basically count how much light in each of these wavelength bands gets through the seawater and through the nitrate into the spectrophotometer. And so this is an example of the spectra here. So this is the red line in the middle. And so this is what so the lamp will actually do a wider range, but this is an example of what the spectrophotometer can actually measure. So we have it from 190 to 370 nanometers. And so this is actually the sum of all absorbing chemical species. So what you're seeing here is like everything that's in the water. It's the salt, it's the, if it's seawater, it's the salt, it's the bromide, it's anything like CDOM, so any particulate matter in that, and you kind of get a wider range. And we do this wider range so we can kind of understand what is in the water as that. But the part that we're really interested in, the part that makes the measurement, is actually in the blue box. And it's this 217 to 240 nanometer band. And this is really important. So on the lower right-hand side, we see an absorbance spectra of a couple of different species that you typically find in seawater. And the really important one is, I've tried to highlight it in dark blue there. That's the nitrate, absorbance peak. And you'll see that peaks between that band. And that's really that's the key piece of the UV spectrum that we're looking at to understand how much nitrate is in the water. So we can look at the spectrum. We can look at it actually two different ways. So what the nitrate concentrations look like from the UV spectra. So we have two spectrums here. One on the top is that we just have deionized water. We have no nitrate in that water, and you can see what the spectrum looks like. If we actually spike that water now with nitrate, you can see that that peak in that range that we just talked about in the blue box tends to go down. And whether that peak gets bigger or smaller, that's actually how the instrument is measuring whether how much nitrate is in the water. And this is actually done with like a linear regression kind of method. Okay. Actually, I did want to actually point out one thing. Sorry, I had to go back here before I forget. And I'll actually go back one slide. It's kind of hard to see in the spectrum in the lower right-hand side, but one of the things is that nitrate and nitrite actually have very, very similar absorbance spectrum. And so you're actually, the SUNA should really, sometimes we call it the SUNA nitrogen sensor, because it's actually measuring both the nitrate plus the nitrate. But in seawater, typically nitrate concentrations are so low that the nitrate actually just you're mostly measuring the nitrate instead of nitrate put nitrate. But if you are in a region that has really high nitrate concentrations, you should keep that in mind so that you're measuring both like that. Okay. And then the last thing that we showed here was the integrated hydrowiper. I'll show this again, but this is a really handy. This is a mechanical solution to biofouling. These are optical surfaces. You have to keep them clean. As we know, you throw anything in the ocean, stuff grows on it. And this actually enables, it just is literally just a brush that goes across the surfaces and keeps it clean. On the bottom right, you can kind of see what we're up against here. And the biowiper works pretty well. Every time it takes a sample, it turns on. And there's a slip ring as well that to allow it not to break should the wiper become misaligned or obstructed, which may happen. Okay, and then the other thing you can do with your SUNA too as well, you can, if you have it in a system, you can actually use this flow cell to connect it to pump systems. So if you have a microcat or maybe like a 19 or something like that, you can actually connect that to a Seabird CTD, and then you can actually get the data at the same time. This also has some added advantages. So the antifoulant that's used in the CTD, that will actually flow through the cell and help you keep it clean. If you don't have it pumped as well, there's also a copper guard for unpumped systems. So trying to keep, if you have really, really bad biofouling, which in some cases you do, and in some cases you don't. So it really depends on your application and where you're planning on deploying it. Okay, so I'm actually going to switch my camera up now. And let's see. And we're going to actually look at a SUNA that I have on my desk here. Okay, so this is our SUNA. This is what I talked to before. So I'm going to go over this a little bit. So again, this is kind of what I showed in the diagram here. Over here you have the lamp, and over here the spectrophotometer. It's really hard to see, but inside here, you can see that there's the gap here, and then you have two optical surfaces in here. And that's really what you're trying to keep clean to keep a good measurement. You have the biowiper here. Even though it's very tempting, don't use this as a handle. You could break it. And you also want to really be careful with the biowiper because it's pretty good. It has a slip ring, so it won't really break. But if you do bend it, there's not a lot of wiggle room here. So you want to make sure it goes in there just right. Okay, so now that we're going to do this, we're going to connect it. And what I'm going to do is I'm going to get out my cables here. So this is it. So this is the cable that will come with your SUNA. It's nicely wrapped up with this zip tie. We have the end here, plug that's going to go into the back of the SUNA in this case. All right, so I'm going to take out the dummy plug. Don't lose this. Put it aside. A good trick if you don't want to lose this little collar here, I don't have it, but is to take a zip tie and just make a little tail, and then it won't fall off. Should do that on that one. All right, so I'm going to plug this in here. And you want to make sure all your pins are aligned. And it just goes right on there. I like to always put that collar on just in case you end up pulling it out. All right, and then the other end has 2 cables. So this one has a USB cable. So this is to connect and talk to my computer. So I'm going to plug that in. And it also has these 2 power cables here. All right, and then I have underneath my desk here, I have a power source. Let's see. I have a power supply down here, and then I can plug it in red here, black here. Okay. You can just, I'm going to note here, you can talk to your SUNA without having it go to a power source. But if you want to test the bio wiper, or you want to do anything like taking data or updating the reference sensor, updating the reference spectrum, you are going to need a 12 volt, at least 2 amp power supply. I spent a little bit of grief this week with an older power supply that I had and didn't realize it was a 0.5 amp. And so make sure you have the right, if it doesn't work, that's probably why. It does take a lot of current to actually get this going. All right, and then I turn it on, and you can have about 10 volts, but I think it does work from 8 to 18 volts. I'm going to put this power supply back down under my desk. Okay. So now that we've plugged it in, I'm going to go back, and we're going to actually walk through UCI. Bear with me while I get my screen ready. Okay. Just bear with my desktop. Okay. And then I'm going to send this live. Okay. So you should be able to see my desktop now. Okay, so what I'm going to do is I'm going to open up UCI. There's a lot of different ways you can access UCI. So one thing you can do, the easiest ways that I do is I just leave a shortcut on my desktop, or sometimes I put a shortcut down here, but you can always look for it. If you type here for UCI, you can always find it that way as well. So UCI 2.03, all right. Make sure you've downloaded the latest version of UCI. We do, you can download that from cbird.com under software, and you should see that. So we're seeing that, you should see this starting up. Taking a moment. Okay. And this is the UCI window here. Okay. Okay, and so the first thing that it's going to do, and I am going to set up, you can see here, this is a pop-up. I will set up my magnifier for later, but this does ask you where the default data location is. I just have it under Documents in UCI, and if you look on the left, you can actually see there's a small folder down there that I actually have on my desktop, so I can access it really easily. You can browse and use anything you want. All right, so you press OK. You've done that, and you can see up in the top left, there's a red bar which says disconnected. So that means that your SUNA is not connected. So the first thing that you're going to want to do is connect to your SUNA. So this window might not be up initially. If it is not, you can go to the UCI dashboard here. So this tab right up here, and I'll show you that in a minute. All right. Let me get my magnifier up. Okay. All right, so here we go. I'm going to go around the screen. Okay, so this is it. I'm going to connect. Typically, if I've connected a new SUNA, I want to try all baud rates, and I want to know which COM it is in there. If you don't know which COM it is, you can go to your device manager and look under COM ports, and if you've plugged your SUNA in, it will say SUNA on there, so it will know. I'm not going to try all the baud rates because I already did that yesterday, so I know that this is the right thing there, and it's trying to connect. I'm going to go back down and zoom out, and you can see what happens here. Okay. Okay, so up on the left here, you can see it goes yellow, so that's transition. So that means that your SUNA is starting to communicate, and now that you've connected, it's turned to green, and now we can start the setup here. So there's a lot of different options here. So this is the SUNA Dashboard. Again, I'm going to press the magnifier, but you know that you're connected when it says green, and then you actually start to see the plot over here. There's no data yet because we haven't plotted any data, but it just comes up so you can look at this. All right. Let me go to my magnifier. And here we go. Okay. So this is the upper left-hand side of this as well. If you have a UCI, you can download this and you can actually click along with me as well. But we can see that there's some information about my SUNA here. So the first thing is I know is that it's connected to COM6. I know how much available lamp time I have. So one thing you do have to be cognizant of with your SUNA is that that lamp has a limited lifetime. It's just like a bulb in your house, all right? Eventually it's going to wear out. And so you know how many hours, it does log how many hours it's been used so that when you do need to send it out for service that we do know. It also has available disk space, and then we also know what the time is as well in the firmware revision. So importantly, there's a bunch of buttons here, but I'm going to go through them. So if I wanted to disconnect, I could press here. Importantly, here is the SUNA settings, so that it sets everything up. That's really if you want to do advanced. If you know all your settings ahead of time and you just want to put them in, that's where you go. But the deployment wizard also would help you, so it walks you through all the steps of what your sampling should be, and then it actually just tells your SUNA to turn off and then be ready to do deployment. One thing you want to do is a reference update, so we'll talk about that later, but that's updating your spectrum to make sure everything matches up. So this is kind of in checking the health of your sensor, your lamp. Transfer files is for when you recover it. You can also check your wiper, and you can use, if you want to talk to it directly, you can use the command terminal. If you do, I do want to show this tab here. This is the UCI Dashboard. If the SUNA Dashboard doesn't come up, initially, you can press connect, and then you'll see a pop-up window that asks you what instrument you want to connect, really similar to what we saw, but it'll also have other examples like an eco or a hydrocycle, which is a different instrument. All right. We do actually have other regions of, we have other drop-down menus for some other functionality. You can connect as well, particularly the SUNA. We have all the sensor data. We can do that again up here. Importantly, under data, it's export log data. You can also replay any data. And then also, if you want to, this is where you'd find anything for the SUNA. So if you want to reprocess your data. So sometimes, particularly if you're using it in seawater, you're going to want to add a temperature and salinity correction, and you need to add that from an external CTV. And this is where you would go to do that. Okay. So, all right, so I'm going to walk through this. Let's see. I'm going to go scroll back down. Oh, yeah, and then your real-time display. Okay. So one thing I can do here is that I could actually just take some data. So I have set this up. One thing I can do, and I think you can see in the small window here, I think you can actually see the SUNA. One thing I can do is I can check the wiper. You may be able to hear it a little bit, but the wiper is doing one check. So that's a good way to just check the functionality. When you start actually sampling, it will also do that as well, because the idea is that the bio wiper does a swipe, cleans off your lens, then you take a sample. Okay, and you can press here if you would like. You could press start. So I actually have this set up, and you could do this to take some data on the bench. You can press start. So you might hear it again. This is going, and I have this set up to take continuous data, and I'll show you how to do that as well. And so right now, it's plugged into a power source, and it's going to be taking some data. There we go. Sorry. It's taking a minute. So it takes a minute to warm up. And then now you can see that it's populating the charts here, and you can look at some data while it's taking it in real time. The other thing you can do is we talked about the spectra. So this is a tab up here. You could look at the spectra of data. This is in air, so you kind of can see all of this as well. And if you want to take the total absorbance, you can look at that too, in a certain wavelength band. And then, yeah, so this is kind of telling you if you want to do any bench testing, this is how you would do this. You can start logging at the bottom. You can start logging this to a file if you'd like. You don't have to necessarily do that, but if you do want to save this later and look at this, if you're doing any bench testing or you're doing it in any way, you can do that. And then you can press stop. And then let me show you how I did this. So I did go to the SUNA settings here. Okay, and so the way that you're going to actually take live data, and I will zoom in again. Okay, here we're interested in the SUNA settings. We want to take continuous data, and typically we want to do, so the idea is continuous data means it just turns on and it's just going to start taking data as fast as it can. You have a couple different things here. You have a frame-based operation. I did 5 light frames to 1 dark frame. So a light frame is what you take when you actually have, take a measurement when the lamp is on, and a dark frame is you take it when the light is off. The reason why you do that is because that's how you characterize the background electronic noise in the spectrophotometer. And then we can subtract that out and get the correct nitrate concentration. You can do a number of measurements to average. I do always recommend averaging. Unless you're really looking for something, if you're looking for the performance. If you're actually sampling in the field, I always suggest averaging because it does take down the noise a lot. That could be confused with the real signal, and it does actually help your instrument be more accurate. If you are doing troubleshooting, typically I actually will take 1 sample to average and I'll go down. The other one as well, it tells you your deployment characteristics, and then also, the estimated frame rate, so how fast taking a sample. You can have an integrated wiper enable, and then you can do a logging level as well. So there's a lot of different ways you can do this. This is all described in the manual. Typically, I just do info, and it gives you one. Okay, I'm going to zoom out of this. Okay, I'm going to minimize this. And the next step, we're going to go into our PowerPoint here. We're going to scroll down. So some of this I'm covering is going to be, it's actually in the slides, and we'll post that at some later date. I'm just walking through some of these slides without them. Okay, so we've kind of done, let me go. I'll go back 1 slide. So we've kind of done some of this. We've taken some data, we've checked the BioWiper, but I do want to talk a little bit about pre-equipment cruise checks, and they are really important in particular. They do help to prevent last-minute problems that can delay or impact a cruise. So it's really important. And if you're not the only person in your instrument, so a lot of places have pooled instruments, you really should do this because you don't know how somebody else set it up before you or what they did if they took it off the shelf. And maybe they were just using it for a tiny experiment, but now it's totally set up. And you should do it as soon as before the cruise is reasonably possible. So, if you need to do it on land in the morning, that totally works. If you need to do it in the lab 2 months before it's shipped out, that also works too. But you should do it as reasonably possible, as close to the deployment as you do, because you never know what can happen to your sensor between then. Okay, so I do actually want to talk a little bit about calibration. A really important part, and let me maximize this here. Okay, a little bit about calibrations. What is a SUNA calibration? So it characterizes the component of the SUNA to get an accurate reading. So you want to understand how the instrument is functioning to really understand when you're looking at something that, to really be able to accurately assess the state of the water in the sensor. And so that goes from the lamp output to the spectral detector. And what I don't actually have on here is the electronics. and the heat as well as this. And so what this does, it really differentiates the no nitrate spectrum that I showed before from the nitrate spectrum. So one thing about the calibration, the first thing is you're going to have to do is you're going to have to determine where you're going to deploy your SUNA. So the really nice thing about the SUNA, it can be used in multiple environments, but those environments have very different optical characteristics, and we have to calibrate it differently as a result. So you really want to choose the right calibration. If you're using it in a freshwater application, so this is typically anything terrestrial, lakes, streams, whatever, you're going to want to use a freshwater calibration. The reasons for this is that typically nitrate concentrations are a lot larger, so we actually calibrate over a larger concentration range. And then there isn't as many interfering species for CDOM or something, or for dirty, or for like muddy water, any material in the water, but we don't have an interfering of bromide, which is actually what happens in seawater. So for that calibration, there's two solutions. So we use a deionized water calibration, and then we use a standard nitrate solution in deionized water to understand that calibration range. A saltwater calibration is a little bit more flexible. It can be used in both seawater and freshwater. It does calibrate over a little bit of a smaller concentration range, and that's because the expectation is that in the ocean, just nitrate concentrations are pretty low. And it also accounts for bromide interference. So we actually do three calibrations here. So the first one is the same, it's deionized water, so water with nothing in it. We do a low nitrate seawater to get the low range, and then a standard nitrate solution, but this time it's in seawater. And so then we can from that, we can actually calculate the bromide interference. If you're an estuary, so a lot of people use these really close to the coast, you're going to use both fresh and seawater. We do recommend that you use the seawater calibration because it will cover both. Okay, so now we're going to do a reference spectra update. And so the reason we do this, it really accounts for the aging of the lamp and the reduction in UV output from it. It also kind of can tell you about the health of the sensor. So if the health of the actual lamp itself, it does actually provide a baseline from which to accurately calculate nitrogen concentrations. It's a little different than a calibration. It just kind of makes sure everything is shifted in the right direction. And it should be done before you deploy every time. When you do make the reference update, it does create a new .cal file. And these .cal files are stored on board, and they're never overwritten. So you can actually go back. So if you say you did like a bad reference update, you can go back and you can do it again, and then you can, or you can use the older one that was good. Okay, so I'm actually going to show you now how to do the reference update. I'm going to start with showing you the tools that I need. So really the most important one first is to actually clean the sensor. So for this, you can use Kim wipes. So they're lint-free, any kind of lint-free towel for that. You're going to want to use maybe isopropyl alcohol. So I have that as well. You do want to get a pretty clean one. Don't use just one from the drugstore, from the pharmacy. It does actually have, we do recommend getting a pretty good laboratory grade one, only because the one from the drugstore typically actually has a little bit of contamination. And so when it dries, it actually leaves other things on the optic. So it's important to get good quality alcohol. And then also what you should use to clean in here. So the whole point is you're trying to clean the two optical surfaces in here. You can also get lint-free swabs, which I don't actually have. So that's for cleaning. So that's the first thing you want to do. You want to have a clean optical sensor because you don't want to get any contamination from that. Okay. So we've done that. So the next step is that we're going to have to fill this area here full of deionized water. So I have my deionized water. This is my desk with my computer. You probably have a lab that has a nice space for it. I do not. So this is, I'm from my house here. So what I like to use, if you don't want to make a mess, you can get these at any pet supply store. There we go. All right. This will collect any of the mess I make. Okay. So this is a really good tip for this one. So the first thing that you're going to do is as I mentioned, you're going to move this out of the way. So your brush out of the way, and you're going to want to seal this up. You know, I think there's two ways that you can actually seal this up. One person suggested one way to do it is if you have parafilm on hand and you're really good at it, you can use that to seal this up. But the other option is just use some electrical tape. So I will cut up some electrical tape. It works just fine. Make sure you're not using like really old, you know, make sure it's like not an old and grody one, because you are trying to keep things pretty clean. And what you'll do is you'll put this over here, and then I will cut a little bit of a length out here. I'll seal this up. All right. It doesn't have to be a perfect seal. You just kind of want to make sure that this is going to stay full of water. And then you can see here, as I flip it over, I have a little gap where I can actually put the water in. All right. So I could put my deionized water in. I could just pour it in, or if you have a little container with a top, but a syringe always works really well here. All right. So you don't have to use a lot. Let me just fill it up in there. All right, let me move my hand. And I'm just gently filling it up. All right. So I put in about 10 milliliters of water, and that's full. So you can have a little, but it's nice that this is a pretty tiny bottle because I can pretty readily available get some, but if you are at sea, you might want some more. Okay. So I'm going to go back to screen sharing. All right. So we've set up our instrument now for the reference update, and now we're going to work with the actual, we're going to work with UCI. So you should see that on my screen here. So now we're going to work with UCI to actually do the reference update. So we've set it up really nice. You don't want to use tap water here. By the way, you do want to use deionized water because the tap water could have other things in it, depending on where you live. And the contamination comes from lots of different sources. Your pipes, the actual water source. All right. Okay. So I've clicked on my reference update. This little window pops up. It tells me what my active calibration file is. So this is what I'm using. It tells me the things that I just talked about. Clean the windows with a cotton swab and isopropyl alcohol. Then I place the DI water into the sampling ball thing, and then make sure there's no air bubbles sticking to the windows. If you don't get a good reference spectrum, that's often what happens, and you can just stick the other clean end of the Q-tip in there to kind of dislodge the bubbles, probably using a flashlight as that. You don't ever want to look into it when it's on really closely because that is UV light. As we know, UV light is damaging. All right, so it tells me what my acquisition mode is continuous. I press next, and then it just goes. It was pretty easy. You have a nice little, and you can see in the background on the right, you can see that it's actually taking data, and I will scroll over there. So it took some data processing, so that's that blue line in the background there. And it's 100% done, so I can click next. And then what I do, I want to compare my change in reference spectra. And so so I'm going to tell you that I have not updated this reference spectra in a couple of years. But this is actually doing pretty well. If you do, so there's a couple of things you do want to look for here. You want to make sure that this is a smooth, continuous line and you don't have any breaks. So that's where we're doing good here. And we also want to make sure that in this wavelength range from about 217 to 240, that you're not seeing anything larger than 10%. If you do see something larger than 10%, that might be indicating that you should update your reference spectrum, but this looks pretty good. All right, and then you can update it as well. And I'm actually just going to do this here because you're going to see. So it's going to make, so we started with the calibration file G, and now it's going to make one that says H. So we have a .cal file. The also thing that it's going to do as well is it's going to make a report file name, which I think is really, really useful. So we can press finish. All right. Okay, and it tells you a new calibration file will now be uploaded to the SUNA. All right, and I'm gonna press OK. And then I'm gonna zoom out here again. Okay. It's taking a little bit. I realize that using Teams has been bogging this down a little bit, so it's a little bit, so apologies. All right, so we get this really nice SUNA reference report update. So it tells you what the reference spectrum looks like. So you get a nice, makes a lovely PDF. So you see the reference spectrum, you see what date it is, all right? And you see the spectra comparison, so you know what you're changing. So you can track the health of your sensor over time. And then it gives you those new count coefficients. So this is just the numerical version in each of these wavelength bands over here. So we're good on the reference spectrum update. One thing you can do as well that I do like to do sometimes is you can look at the SUNA and you can compare your calibration, all right? So here, if you want to see how your calibrations of files have changed, you can select your first one. So I will select F. Oh, I'm sorry. And this is actually looking at calibrations that I've downloaded onto my computer. So we're not going to look at the most recent one, but I can look at 2 in the past. And then I'm going to do my second calibration file. So G. So, and then I'm going to compare. All right. And you can see that that's a % change in the reference spectra. All right. So that was from the other 2 previous ones, and that's pretty close. That's typically what you'll see. I think we see a little bit larger one, but again, we haven't really updated the reference spectra, and I've been using this a whole bunch. And so that's where we're getting these changes as well. All right. Okay, so you've done that. I do highly recommend before every deployment that you do operate the reference spectra. It's just a really great way to keep your lamp life up to date with the ionized water. So now you're ready to deploy. And you're going to use your deployment wizard. So you can either do it SUNA settings, but the deployment wizard really works really nicely, and I really recommend using it. And we're going to talk about, there's a couple of different ways that you can actually deploy this. Okay, and I'm going to go up. Hold on. There we go. Okay. So there's different operational modes. Continuous is if you just wanted to turn on and take samples all the time. You typically use this in a periodic mode. What we're looking for here, using the continuous in a profiling setting. So if you're attaching it to a CCD or a boat or some kind of autonomous vehicle, you can do it like that with unlimited battery life. Periodic is what we're going to use for moored applications. The other one you can do as well is polls. So periodic just means that it just turns on after a certain point, and then every hour, and then takes data, stores it, and then waits and takes it again. Polled sampling is if you're actually talking to the instrument itself, and you can say, I want you to take a sample now from an external controller, and then it will do that. And then we also have settings like if you want to put it on an Argo float, which they're on, the BGC Argo floats, they're on there as well. So we're going to pick periodic. Oh, and fixed time is if you're on your bench and you want to just set it to go on for an hour immediately, then that's what you would do. All right, but we're going to work with periodic here. Okay, so here we go. So we have a sample interval. Typically, we're not going to do it that high. There is a battery endurance calculator that you can use to figure out what your sample interval is for your settings, and that is available, I believe, on the website, so you can find that as well. And your sample interval, so we have only a couple of options here. We have a variety of options. Typically, we can do 1 hour, all right? So now it's going to take a sample at 1 p.m., at 2 p.m., at 3 p.m. If you would like it to take a sample at maybe like 1:01 p.m., because I don't want to go through, or 1:10 p.m. every hour, then you would do an offset, and that's in seconds. So in this case, it would be 600. All right. So that's 600 seconds equals 10 minutes. So it would be taking a sample on the hour plus 10 minutes. So every 110, 210, 310, 410, 510. You should do a frame. You can do two different ways. You can do a frame-based operation, so how many frames you want to take, or a time-based operation as well. You can have it go on for 5 or 10 seconds. I like frame-based operation because then you get the same amount of samples every single time. A time-based operation, as you go and change your integration period, it could change a little bit. I typically like, for more applications, I like to take about, let's see, I think I've suggested about 20 to, I think I like 20 frames. And then I like to take an average of 5 of those. So you get 4 samples, and then you can get some dark counts as well. So that's the way that I like to run it. You can do 30 as well. You don't want to go out to 100 frames. And there's a reason why for that, because as you extend it longer, your lamp is just like the older lamps in your house. Like if you've ever had an old fluorescent lamp, there's a lamp turn on time. So when it first starts, it's not as bright as if when it's been on for about 20 seconds. And the same thing happens in your SUNA. And so the key is to actually just take the samples at the same time in the dimness that it is. So after it starts off. So if you start going really long, you start getting into this weird, it's not a steady state. You're not quite approaching a steady state, and those measurements can be confusing and less accurate. So we suggest a shorter amount of time. Now, in some cases, it might be longer, but I do want you to keep that in mind. It really depends on your application. Okay, let's see, we'll go up. Okay, you can have a data transmission. If you are not planning on taking live data from this instrument, you just want to turn this off, right? If you're not planning on having anything connected and transmitting it, you want to turn this off. And the reason why is that the full data will be stored inside the SUNA memory, but you're going to actually save a little bit of battery and extend your battery life because you're not spending all that power trying to talk to something. If you do want to do your instrument logging file frame format, I do suggest you just do full ASCII, and then you can choose how much you want to do your log file creation. So by sample event, by file size, it really depends on what you want to do in this application. It's kind of whatever your preference is. All right. So so this instrument's actually been calibrated for freshwater. So I'm going to deploy it in freshwater. If this was seawater calibrated, I have both options. And the other thing I do is I can measure a bromide trace. So in some regions where you're deploying with freshwater, you do have bromide interference. So you can do that as well. So your instrument will kind of help you figure out if you have bromide contamination. Okay, and then the last one is your deployment report. I put my name in, operator Kim Martini. I can do any deployment comments here, SBU 2021, all right. And then I can show where I want to put it out and I can view the report. Okay, so now I'm ready. I'm going to store my settings, disconnect the instrument, and generate the deployment rights. So before I do this, I'm going to zoom out only because we're going to see some things happen in the UCI. All right, so it's thinking really hard. All right, and I have my deployment report here. All right, and here, this is everything that I've put in here. It has all the functions that has put into this. These are all the command line commands that UCI is setting to the SUNA to make your deployment happen. So this tells you, is a great report to tell you what you've done and how you've set it up, which is really important because sometimes as things break, it could be, you want to make sure that it's because, if something happens and your data doesn't look right, it's not because of a weird setting, it's because of something that's happening in the ocean. Okay, and then lastly, so I'm going to minimize this again. All right, so my SUNA is like kind of ready to go. And it's not taking any data right now, and I'm going to bring my PowerPoint back up. Okay. Okay. I do want to talk a little bit about cables and connectors. Okay. There we go. Okay. Before you do deploy, you do actually want to check all cables and connectors. If you're going to be talking to anything in real time, this is really important because you just want to make sure everything's clean and you're getting the nice data. You do want to remove your cables from the bulkhead connector, so the bulkhead's what's on the instrument. You're going to want to clean and relubricate them, dummy plugs. I do think you can use Kim Wipe. You do want to use something like DC4, which is an electrical insulating compound. That's for dummy plug and connector lubrication. Don't use anything with silicone because it can break down the rubber. And then last thing, depending on you burp the air out of the cable if you have that kind of cable. I do think that if you do have really dirty pins, particularly if they come back, you can use, if you've ever gotten a free reusable straw, they come with a tiny wire brush, and that is excellent for getting into those connectors. So just be really gentle with that. The next thing you want to do is, that's really important. You do want to make sure the SUNA is mounted incorrectly. So really the point that you really want to take care of is where the optics are. So that connector there. And you don't want to have too much strain on that, because if you actually torque the body itself, because you've clamped it down in sort of like a weird way, hose clamps can have a lot of force and you can torque things. And if you misalign that, you won't get great data. Your data might have a problem. And really, and even worse, if you don't do it right, you could actually break the housing. And so in this case here, I'm showing a picture of a brush. You can see the insides of the SUNA here. They only used a single mounting point, and they put this part in the flow. And what happens is it just broke along there. So you're going to want to use 2 mounting points. This is a nice diagram here on the right that shows you the proper way to do it. So you have a clamp on the bottom and a clamp on the top. We have a whole bunch of mounting brackets available, so you don't have to re-engineer this yourself. And these work really, really well. And they also work with the BioWiper as well. I do want to say, please don't mount it on the BioWiper. The BioWiper is, it's not designed to carry those kind of loads. It's just designed to use a little wiper on your instrument. All right, so now that you've mounted it correctly, you got to wait. However long that is, a week, a month, a year. And so the next step is getting your data back. Okay, so once you've cleaned up your SUNA, so you've probably put it out in the field, you may have some biofouling, you may need to clean that up. But you do want to transfer your files to a computer. So I'm going to connect back to my SUNA. All right, and I'm going to show you how to do this. All right, so because I've set the SUNA to deploy, it has disconnected, so I will need to reconnect again. All right, still on COM6, still the same baud rate. Remember, so that's nice. All right, it's thinking, so it's going yellow here. It's transition. It knows it's talking to it. And then now we're ready to set up. All right, so the next thing we want to do is we're going to want to transfer the files. So right now, all the files are in the internal memory on the SUNA right here. And we're going to want to transfer it over to the computer over here. So we're going to press transfer files. Okay, so there's a bunch of files that you're going to want to be able to download. So on the left is where I have my local files. So this is my computer, and then I have the instrument files. And you can see here, I will do this by date. You can see here that I have a bunch of files here, and then I have a bunch of files here, and I have 2 new files. And so if I would like to connect them, I would click, I'm going to click on the small one, and then I would also like to transfer them over here. Okay. And I clicked on this knowing that it might take a little bit, but it's working. And you can see there's a nice little bar that tells you that it's going on. The other thing too is that when you plug in your SUNA, let's see if I can pull this up correctly. Oh, your SUNA also comes up on your computer as a USB drive, and you can access all the information. So in the DAT file here, you can see that these same files that are in here are in here, and they're marked as CSV. So Excel thinks that that it's theirs, which is fine. You can open this up with a text editor. I like to edit it with Notepad++. Taking a minute. Again, my computer's pretty sluggish with Teams today. And this is what it looks like, the CSV. You could actually download this completely if you'd like. I'm sorry, I think, let me open this up. Sorry, let me open the other one up. I believe the other one has been overwritten with a human readable. No, this is the same one. Okay, so this is what it looks like. You have a lot of information here. So you have the header information that tells you kind of about how your SUNA is set up. And then each one of these is a sample. So this one has a lot of information. There's a decoder in the manual, but what this is, it's telling you information like the temperature, this is each of the counts in each of the wavelength bands. And then it will tell you here on the left, it will say either SAC-DF, which is a dark frame, or down here, SAC-LF, which is a light frame. So you can see these values are a lot higher because your lamp is turned on and then your lamp is turned off. Okay, so hopefully we've uploaded by this point. Oh, we're getting real close. Okay, and it will upload it. And this was just some data I took in my office. All right. I do actually want to talk a little bit, that reminds me, I should talk a little bit about office data. Your SUNA is designed to be used in water. And when you use it in air, and it's designed to be, the water is actually designed to be a heat sink for the lamp and all the internal electronics. If you do run it on your bench, you may find that it starts turning on and off. That's because the lamp is just, the internal electronics are getting too hot. I think there's a cutoff at about 31 degrees C. And so it will turn the electronics off to save them from being fried. Normally, when you put it in water, this doesn't happen because water is a giant heat sink. But I do want you to be aware that is a known, it's just because of the way that the SUNA is designed. Okay, so the other thing you can do is you can have log files here. So we have lamp use, system log. And then lastly, we have all of those calibrations we have. So we have a whole bunch of calibration files that are on here, and including the one we just made today. And you would want to transfer them to your computer using this method. All right, so now that we've transferred everything to our computer, what we can do, so there's a couple of different steps here, but I'm gonna go through the simplest step first, and that's really just exporting this data to a usable format. So you've already calculated the nitrate on this. So this has been done on board. Part of that really big file that I showed you with all those numbers in there is a nitrate concentration. And what you're going to want to do is you can export that log data under data here. And this will make it nice to use in an Excel format. Okay. So here we go. When I do that, I'm going to zoom in again so we can make sure that we see everything. Okay. We're going to look for our file name. So I'm going to browse here. I'm going to look for a SUNA log. If you don't see anything, go to SUNA log data. And I can do that here. I will just choose this one. All right. Then I will go to next. Shows me my instrument output format, if that makes sense. I can go to the top and you'll see there's a lot of things, the date, time, the nitrate concentration in various units, specific wavelengths, and then all of the wavelengths here, and some more information. And then you're going to want to export it. So you can either do it as CSV or an Excel workbook. I'm just going to do it there because a lot of people have Excel. You can do a local timestamp or UTC. So UTC, I kind of recommend doing it. Local just ends up taking what's on your computer. And then you're going to want to do a file name. And then in this case, it's doing as an XLX. If you do a comma separated value and you save it in the same file, you will want to append it a little bit just to be like, put your initials on or something. I always put my initials just so you can see, because it will overwrite the CSV that you've just downloaded if it's the same name. Okay. And then the other thing I've done too is the graph data samples. And this is really useful because right now I've downloaded my data and I really want to see what it looks like. All right. So it's exporting. While it's doing its little line, I'm going to zoom out. And then It's showing me my data. Okay. And it is doing it. I'm going to close this dialog when the expert. Oh, it's done. Okay. So I didn't have the checkbox clicked. Okay, so it has hit some data. I mean, it's not really perfect or anything, but here we can see that I was using it in my office and I was doing some things and I could see what the data looks like. This browser is really nice. You can do an auto range here. I'd like to do default ranges for this one. Oh, it didn't take any data. So we can always zoom in if you want. You got to go from the top left down. If you try to zoom in this way, from the bottom right up, which I often try to do, it doesn't work. So you have to do it from the top left down. And you can see that you have relative humidity. You can see that, like I was talking about, the temperature of the spectrometer is warming up because your lamp is on. You can see there's some other information here as well. But this really, it's a nice graphic to see what your data is to do this. And then the last thing I kind of just want to talk about too is if you ever have an old data file and you do want to look at it, you can replay your log data. So you can open up any of these CSV files and you can open it up. And then the last thing that you're going to want to do too is if you are using this in seawater and you do want to put this together with any CTD data, you will have to reprocess the data. I'm not going to cover that here. That is covered in some app notes and the manual. But this is where you'll go for that. All right. So I think that is it for our content here, and I don't know if there's any questions, but I haven't been able to look at the chat. All right, thanks everyone. I'll look if we have any questions in the chat. Okay. All right, Greg, did you see any of these questions? I'm sorry, I haven't had a chance to read them.
Yep, we've been answering most of them so far. I'm looking up an answer for this latest question about temperature ranges. I don't think that the temperature is recorded during the reference updates, but let me follow up with our team here.
Okay, I can answer. I'm just going to read Taylor's question because how many versions of the UCI software have been released? In 2019, they had an instance where the newer version did not connect using the RS-230 connection, and they had to revert to an older version of the software. Because that issue haven't updated to a newer version of the software. Has it been confirmed that this version 2.0 works for both communication types? Yeah, so there have been, according to Greg, there have been 4 versions. We are always working on updating versions. Yeah, again, it doesn't look like there's been any major changes, so this might be a tech support issue. Oh, there were 8 releases. All right, going through all this. Okay, and then the last one, the reference update. All right, what is the effect of the temperature on the reference update? Should it be done at deployment temperature? What if the deployment temperature varies significantly? It's best practice to use a reference update as close to it as possible, is it? But we do realize that that's not always possible, and it's actually really, really hard to actually. So one of the things we don't recommend. So the easiest way to get it to the temperature would to actually be submerge the entire instrument in water, but then you'd have to actually submerge it in DI water, and you need to make sure you keep it clean. And there's so many other variables to that. So if you could do it kind of at the temperature you can do it, it's great. try not to do it like a really hot room if you're not going to do it in the hot things. So if, you know, you can take it outside and do it as well. All right, and then Taylor had a question on the reference cal temperature question. Is there a way that the temperature is recorded during the reference cal? I think, Greg, you're looking that up.
Yeah, so the answer to that is no. The SUNA is not recording the temperature during the reference updates, nor is that information logged in the cal file. So the way that we do this at Seabird is we calibrate SUNAs in a temperature-controlled bath so that during those updates, its temperature is tightly controlled and known by us. And we enter that value as a static value into the calibration file. The SUNA itself is not measuring the temperature. So best way to do it would be to know, I guess, the ambient temperature in your laboratory while you're doing the reference updates. I believe we use a bath of deionized water so that we don't corrode the connector at all. And then that is passed through a chiller that provides a really consistent temperature. And so that's helpful because you know, in air the temperature can change a lot pretty quickly, but in water, once you have a consistent temperature, it's going to stay there for, it's going to be a lot more stable. So if you have the ability to do your reference updates in a bath like that, but obviously not everybody can do that. We have some pretty specific equipment. Actually, we put a YouTube video showing sort of the a brief overview of how we calibrate SUNAs at Seabird, and clearly we've got a little bit more stuff going on. So best case scenario, know the temperature of your reference updates and keep a log of that.
Yeah, and to kind of add into Taylor's note here that they try to typically do about 10 light readings to have the internal lamp temperature avoid from heating up, and that is actually very important. One thing you can do to avoid this is do your reference update. Don't actually turn on your lamp before you do it, so you have it in a nice cool state. Because that would be as close to mimicking as what your SUNA is going to do in the water, right? So if you're kind of just, it's been sitting there for an hour, it's at a pretty cool state, and then you turn it on and you take a sample, you're not getting that much heating. And so it does actually, in air, it does take a while for the SUNA and the internal temperature, because you don't have that giant heat sink anymore. The air is not a great heat sink. It takes a while to get back down to that really cool temperature again. So if you've just been like fiddling around with the SUNA for a while, that is not the time to take a reference update. Like, go grab a coffee, lunch with friends, come back in an hour or two, and then do it again. Okay. We have a question from Guillaume. I want to put on a mooring per year, at what frequency can I sample every how many hours? So there is an endurance deployment endurance calculator for that. It just really depends on how many light and dark frames you want to take. It also depends on, so the light and dark frame, so that's really important. So it depends on how noisy you think your signal is and what the ambient conditions are. And also, but you will have to use the deployment endurance calculator as well. And I don't know, Greg, do you have a link to that? Didn't have one up.
Yeah, actually, the deployment endurance calculator for SUNAs is built into UCI. So I believe you should be able to access that, I think, from the deployment wizard.
I'll have to look into that.
Yeah, I guess you went through the deployment wizard. Yeah, maybe you can take a look at that. I can address this next question. Is there a recommended minimum voltage or current supplied to the SUNA when using the SUNA external battery? Several voltages and current metrics are recorded in the data file, so I usually check. Do the data start to get compromised in any way if you're running at lower voltage supplies, but still getting a successful full set of readings? No, the answer is as long as you're getting readings, that means that your power supply is providing sufficient current for the SUNA to take a sample. As some of you might be aware, the SUNA is definitely a bit of a power hog, especially with a high startup current. And so what can happen is that if you run at a voltage that's too low, or you find that your power supply isn't providing sufficient current, you might get brownouts here and then. And so our support team is telling me that those can show up as lamp malfunctions or data processing errors. But if you're getting a sample, like a true nitrate sample, your current or power supply is not going to compromise the quality of that data. It's just going to prevent you from getting data in the first place. The minimum that we recommend is 9 volts DC, able to supply up to 1.5 amps. So 1.5, it's pretty high.
And it looks like we have another question. Any recommendations for dealing with drift over time? Is that something you would handle with a final reference spectra update?
This is me. And yes, a final reference update would be a really good thing to do. So we're going to assume that if you're sampling at a pretty constant rate, that your drift is linear with time. So unless you have any like major fouling events, so fouling is episodic, but if it is drifting with time just because of the lamp, then you can do it with a reference date and then update it accordingly. So you would just do a linear drift correction on that one.
And then to the last question, Matt's question, is there a way to name the output files while setting up the deployment rather than the files being automatically named? X, for example, Greg is looking into that one right now.
The answer to that one so far is I don't think so.
Yeah, I think that's just it's just the way that the SUNA kind of just is able to track its data files and built in with the firmware. But I do believe you can change them in post-processing. So okay, we do have a battery estimator Excel file that we occasionally use. I know that people do this. We'll try to make that available. It's one that's used. I can just show it to you. It's pretty straightforward. Let's see. I will just share my screen. I believe, okay. And then, okay, you should be able to see now an Excel spreadsheet on my desktop. You can use this. It's pretty simple. It just tells you what the boot up is. So that's the boot up for turning on the lamp and everything. That's set. You can send it however many times it's sampling, so everything's in seconds here. It does have the milliamps already in there as well. So say you're running it for 5 seconds. Oops. Oh, I have to enable editing. I cannot edit this. All right, here we go. Oh, can you still? Hold on 1 minute. It booted me on. Okay. There we go. Okay. So you can see the spreadsheet here. I'll zoom in a little bit more so we can see this pretty well. Okay, so it tells you how much running. You can do how many seconds. There's nice little, if you glide over it, it tells you what it is and how to set that up. And then you can do the wiper here as well. And then it will tell you kind of how much your capacity is in events per day and milliamps. So it tells you the number of days estimated for deployment. So in here, the way that it's set up is that you would have, and the wiper is kind of just an estimate of how long it takes to wipe. It's either 15 seconds for the SUNA, or if it doesn't have it, it's 0. And then down here in the blue, it tells you the estimated number of days for deployment. So it tells you your capacity as well. So that will give you a good idea for that. And I think this is typically when we do battery estimations, we're very conservative. So it will go longer. So it's really one thing we do try to do is have a little bit of a buffer, So if for some reason that you always, so it's best to always just be able to sample a little bit more than start sampling early. All right. All right, there's a lot of questions here. Hold on.
Okay, I can take this latest question. SUNA V2 with an SE25 on rosettes. I think I've seen this particular SUNA before. Yeah, okay, so this is a SUNA in a profiling application connected to a CTD. Bob, I don't recall if you're using only analog or if you're also connecting the RS-232 outputs to your 25 plus. But let's assume it's only analog since you mentioned CSAVE. So I posted a link here with instructions on how to configure your SUNA to work for analog output to be connected to a CTD, like the 25 plus, the 9 plus, or the 19 plus V2. In that regard, it kind of just outputs in analog voltage in accordance with your nitrate concentration. So you can do profiles of nitrate collected by your CTD. When you're doing this, you can use the software CSAVE. That's sort of our data visualization software, primarily for profiling CTDs. So you can look at the data coming from the SUNA in real time and maybe identify like the nitrocline or something to identify when you might want to take a water sample and process that in the lab. Okay, so one, would you recommend us using the pumped water through our SUNA? We currently don't. I would say that with pretty much all applications, when it's seabird, if you can pump through it, it's going to be better. We do offer a flow cell for the SUNA V2. It's this little piece that fits into the little flow path, the optical window thing. And you can have water flowing through there. If you can connect that to your CTD, your CTD's flow path, that's a good way to get your samples aligned. You'll know that the water that's flowing past your conductivity, temperature, oxygen sensor maybe, is the same water that's flowing through your SUNA, so you're not sampling separate parcels of water. But if you don't, I will say that the analog output from the SUNA is it's pretty rough. It's not as precise as like digital measurements that it's making. And so what some people will do is they'll either have both the analog output and the digital output being sent to their CTD. The analog output they look at for just sort of where is the nitrate max, where's interesting features in the water column with regard to nitrate. And then they'll use the digital data from the SUNA as the data that they actually report, or they'll upload the data from the memory, and that's the data that they report. So that is to say that the precision of your analog data is not really up to snuff when it comes to the digital data that it's actually recording. So if you're not using a pump, it's really probably not a huge deal. You're still going to see the nitrate max and everything that's important for water sampling that you're looking for in a real-time application. And there is not a way to do the salinity and temperature correction in CSAVE. You're doing the right thing here using user polynomial in your con file. So what that's doing is taking in that voltage coming from the SUNA and converting it using a polynomial to nitrate. CSAVE isn't quite smart enough to do the salinity and temperature corrections. So best thing to do is to use that analog data from CSAVE to look at just general features, and then upload your data from the SUNA later on to get more precise nitrate.
Chatting away here, my mute on. So we do have a question. What's the best way to check if your SUNA needs to be sent in for service? There's definitely lamp time. So if your lamp has been on for a long time, there is you can check if it's been on too long. One thing that one thing that you can do as well is you can actually check your calibration file. So that was, I went through there. You're gonna wanna check the most recent reference update against the last calibration that was done at Seabird. So this might be, depending on how many reference updates you do, this might be a couple letters back. And then you can see if it shifts more than 10%. Typically, that's a good time to send it in for service because something in the lamp has shifted as well in that. And then also, yeah, I think we're getting some updates from tech support. So let me read that and then get that. Greg, do you have another question you're going to answer?
I just posted a reply to the question about output files. So basically, the naming formats like A00000X, for example, that is maybe not the easiest human readable thing, but it does have significance where the files will be named automatically based on a logical structure. So then you can use the name of the file to identify, I guess, some details about the data acquisition there. I put those details as a response to that question, Matt's question about output files. So take a look at that if you're confused as to why we name our files the way we do.
Okay, and then we have some more answers from tech support on when to send it in. So more specifically, if the SUNA has lamp hours over 750 or humidity over 30%, we do recommend sending it back in for service. If you do run a self-test in UCI and see the maximum light counts below 20,000, you do want to contact tech support. So just email them your results and say, hey, I'm not really sure, do I need to bring this into service? And they'll know, and they can guide you on that as well. But it may be due to service, but it'll still work. So it'll still operate. Your data might just not be as accurate as the spec at that point. Okay, make sure we're not missing any questions. There's a whole, oh, there's a new one here. I think we've published everything. Greg, do you see any other questions?
Nope, I think that we have addressed everything so far. Going back through history, looking pretty good.
It looks like Bob just replied and said the RS 232 to the 25 plus. I don't know if that one was already answered.
Okay, Bob, so are you using, and unfortunately you can't talk to me right now, So everybody, if you click on the link that I put in there, cbird.com/technicalpapers/SUNA analog outputs. At the bottom of this, there is a Y cable. This is the dual serial / analog cable. So this is what I was talking about, where if you're using this cable, you can obtain both the serial data. So Bob, maybe that's the RS-232 data you're talking about, as well as the analog data from the SUNA, if you've configured it properly. So it's going to output nitrate in two different ways. One way is just as an analog voltage, which, as I mentioned before, is a bit rough. It's more of like an estimation than it is like an exact value. And then you're also going to get the RS-232 output from the SUNA, which is your exact value. In that case, the CTD is acting as sort of like an RS-232 data logger and just appending the data it gets from the SUNA to the samples from the CTD. So then you have this pretty clean nitrate value just right next to your CTD data. Note that is just the straight value coming off of the SUNA. It doesn't have temperature salinity applied to it. So then in many cases, you'll still want to upload the data from the SUNA and then reprocess that in UCI if you want to do those corrections.
Okay, I don't necessarily see any more questions. I do want to say that this session will be uploaded to our website, so it's in the chat for this as well. And I do actually want to say thank you to our tech support team. So that's Dave Selfie and Chris Chesser, who have been helping us answer these questions. You've probably talked to them before, and so they're the real experts. They really do this. Also, Natalie Zelinsky, who used to be in tech support but is now in product management, also really helpful. And then Lindsay Biondo for helping us in the background with all of this as well. So all of our other tech, our AV needs and everything. So Greg, is there anything else you want to add here?
Nope, I think I'm all good here.
All right. Let's see. Well, thank you everyone for coming. I do want to say thank you again for coming. If you do, we do actually have a survey, and if there's things you want to see us cover, particularly more in SUNA, there's a lot we can cover in SUNA. We know we didn't cover it all here, and so we're going to break it up a little bit so we have good little chunks of all this information. Thank you again for coming, and have a good Thursday, whether it's morning, noon, or night.
Yep, thanks everybody. I just put a link to the survey sort of at the bottom of the Q&A, so please go ahead and fill that out. There's a good chance that you'll be one of the few people to fill out the survey, and then we'll be teaching exactly what you're doing for your application, so consider it free training.
Excellent. All right, thanks again, everyone.
Bye.